Hey everybody, hot on the heels of our stunning success with the acetoacetic acid synthesis, which we had last time, which I completely spaced out on calling it that because I am awesome. We are going to now do the melonic, not moronic, moronic ester synthesis. And the core of the melonic ester synthesis is this. This is called diethyl malonate. Now, the malonate half of this comes from this. Melonic acid, natural biological byproduct, melonic acid. There used to be this big mnemonic for remembering all the bis acids. Oh my, such good apple pie, sweet as sugar. No one really uses it anymore, but old folks like me. Now, the melonic ester, in this case the diethyl malonate, is sort of special when we use it because this central proton actually has a pKa of about 15, which puts it right at water and right at a regular alkoxide base. Now, the reason that this acid, that proton is so acidic is because it's smack right in the middle of two carbonyl groups. So your options are doubled for the enolate resonance structures. Whoops. Option 1 and option 2. Clearly, these are both not happening at the same time. Sorry if I gave you that impression. But you do have two sites for resonance. Therefore, this is a fairly acidic proton. So what do we do with it? Well, a lot of this melonic acid syntheses equal the acetoacetic acid synthesis, where the acetoacetic acid synthesis gave you a substituted ketone when you were done. The melonic acid synthesis gives you a substituted carboxylic acid. Now, if you don't mind, or even if you do, it's my show, let's go ahead and take a look at how. So here is our diethyl malonate. First thing we're going to do is apply the alkoxide, and let's do ethyl bromide this time. And this is what we get. Don't worry, we will go through the mechanism in just a few minutes. And now, for our next trick, let's use alkoxide and, let's do benzyl bromide, because who doesn't need to be dragging around a big aromatic ring for no reason whatsoever in their lives? So, we haven't done anything to the ester yet. It's still intact. And here's our intermediate. We heat this up with acid. Again, this is not enough heat to decarboxylate. we just go down to the malonic acid derivative now, and this is the point in sprockets where we put the spurs to it. We really heat this up. So to represent the difference, I'm going to say delta as our really strong heat. And then what we get out of this is that. And a carboxylic acid and carbon dioxide. This is an especially useful reaction, ladies and gentlemen, because there aren't a whole lot of ways of synthetically, that is not from nature, making very substituted carboxylic acid molecules. So let's go ahead and look at the mechanism, and then we should really discuss a little bit about the stereochemistry of this reaction. Everyone's like, ick, stereochemistry. So our first step is deprotonation with the alkoxide. Remember, when you're doing ester enolate work, the alkoxide you use has to match the alcohol portion of the ester. So here we are. Let me get rid of that because it's kind of ugly. It's like the obstetrician said the day I was born. This is gonna get ugly. All right, so there's our methyl iodide. Reform. Whoops. We don't attack the hydrogens, we attack the carbon. And knock off the halide. Yes, I realized I switched out a bromine for an iodine. Sue me, creative license. And now we're here. Now, what I have to point out is this carbon is achiral. That is not a chirality center. And here's why. If you look all the way back over here to this carbon, which is your nucleophile, you'll see that that is sp2 and therefore planar. And because it is planar, there is no specificity towards stereochemistry. So this can come out R and S in equal portions. Now, I kind of used up my space there, so let's redraw this. Another base, we pull off the proton, make an enolate. We get here, and we do the nucleophilic attack on the benzyl bromide, and we get here. All right, believe it or not, this is where I'm going to stop this video. The next video is just going to be review of the acid catalyzed hydrolysis of that molecule and the decarboxylation one more time because it couldn't hurt you to see it. That means the next video is essentially review. And after that, I've got one more to show you tonight, the Dieckmann condensation. All right, so I'll see you all soon.